So if we're doing the midpoints, what we want to do is find the middle of each of these subintervals. Well, remember when you want to point halfway between 2 points, you add together the ends and divide by 2. So -1 plus -1/2 is going to give me -3/2. But when I divide that by 2, it's like multiplying by a half. So that gives me -3/4. So my midpoint here is -3/4. And then add your delta x, add a half to -3/4, you're at -1/4. Add a half to -1/4, you're at 1/4. And then add a half to 1/4 and you're at 3/4. So for this particular work with our midpoints, I have my values that I'm going to run through the function halfway through the intervals, and then I draw the horizontal bar back and forward to make that subrectangle. And again, for the midpoint, I go up curve, horizontal across and down. So halfway through the interval, go up to the curve, horizontal both ways, draw the rectangle, and then halfway through the subinterval, go up, hit the curve, horizontal left, horizontal right, and shade in your rectangle. Okay, so when I look at then my idea of my values with my midpoints, my heights are going to be at f of -3/4, which -3/4 quantity squared is 9/16, plus 1 gives me 25/16. And then f of -1/4, well, -1/4 squared is 1/16, plus 1 is 17/16. F of 1/4 is also going to be 17/16, and f of +3/4 is going to be 25/16. And so now my approximate area from my midpoints is my height times my width of my delta x. So 25/16 times 1/2 plus 17/16 times 1/2 plus 17/16 times 1/2, and then plus 25/16 times 1/2. So that gives me my 25/32 plus 17/32 plus 17/32 and plus 25/32, which is 84/32. And 84/32 gives me 21/8 for our approximation for that area using our midpoints. Now these values again will be off a little bit because they're each approximations using different endpoints, but they will be relatively close. And if you look visually at how many square units of the scaling that you have are enclosed in that, you can look at the approximation and see if it's a reasonable value or not.